Hello everyone. So in this video we are going to solve treetop tree house problem, which is advent of code day 8 problem. So in this problem you will be given a set of integer, which is a tree height. Basically this is basically a jungle where there are lots and lots of tree, and you have to find out the tree inside the jungle with whose height is less than the all tree, means in the present in the all four direction. So for example, if you take, so suppose you are sitting here. So these all edge tree will be visible to you, right? And if height of the tree is greater than the height of edge tree, then that tree will also be visible. For example, this one. So 2, on the edge, one tree is present with whose height is 2, and the another tree is present behind it, and that tree height is 3. So this tree will also be visible, right? And if you see this one, 3, this one will be not visible from here, because height of that tree is exactly same as the current tree. So that tree will not be visible completely. So we have to find all the tree which will be visible from the outside. So if you think, then all edge tree will be always visible, right? Depending on the any height. So it doesn't matter what is the value of that height, it will be always visible. Okay, in case of 0, suppose any tree height is 0, then that tree the tree present next to it will also be visible, because 0 tree height means it is there are no tree there. So the tree around it will be visible from the outside. Okay, so if you see this example, so here it is saying, all the visible tree, all of the other tree between. Let me just walk you through the example. So here it is saying top left 5 is visible from the left top. So if you see here top left, this one, so it is visible from outside, because there is one tree which height is 0. So it is visible from the top. Then if you see from the left, then it is also visible from the left. But if it is not visible from the right, it is not visible from the bottom, because the tree in the bottom has equal to height of the current tree. So it will be not visible from the bottom. So what we will do to solve this problem, what we will do, we will convert whole this jungle into a 2D matrix. So here we have set of trees, so we will convert it into 2D matrix. Okay, and what we will do, for any index, suppose this is A B C D E F and X Y Z something. Okay, for any index we will find if tree present in the left, or tree present in the right, or tree present in the right, or tree present in the left, tree present in the top, and tree present in the bottom are visible. If any of the if any of the side is visible, then we will consider that tree is as a visible, and we will add that index. Like suppose the index is I comma j for this E, then we will add this index into the visible set. Okay, we will add that into the visible set. Next, what we will do, we will first try to count all the tree present on the edge, so that we don't have to calculate the edge of the tree. So we will calculate the all of the tree present on the edge. So we will use one formula. So we will use one formula to calculate all the tree present on the edge. So for example, suppose there is m row and n column, then total tree present on the edge, total tree present on the edge will be m into 2 plus n minus 2 into 2. You can calculate this, you can use this formula to get all the tree present on the edge. And next what we will do, we will run two for loop, one from one for loop from 1 to the number of row, and another one also from 1 to number of column. Okay, and we will apply, we will find all the all the uh, all the tree which is visible from any of the side. Okay, with the help of this thing, means any of the side. So let me just walk you through the code. I'm not clearing this up, so it will be easier for you to understand the code. Okay, so here is my code. So if you see, on the first line I'm just converting all the text to the matrix, 2D matrix. So here I'm converting to 2D matrix. Okay, so here I'm converting the input given into 2D matrix. Now here I'm taking calculating number of row and column, and this is the formula which I have told you here. This is the formula to get the number of tree present on the edge. So you can use this formula to get the number of tree present on the edge. So now move to the next. So here I have taken a visible set. So this set, why I have taken this set? This set is I will be using to add the indexes which is visible from any of the side. Okay, so before going through this function, let me just go to the for loop. Let me just go to the for loop. Here I have just defined the score. So this score is actually a part 2 problem part, so I'm not going to explain it right away. So here I have written two for loop as I explained. So why this for loop, two for loop? Because we have to iterate through all items present in the matrix. Why I am running this for loop from one index? Because the age we have already calculated. And why we are running from to m minus 1? Because this is because we have already calculated the age. So if so, I was wrong here. So we have to subtract it by minus 1, because age we have already calculated, right? So we don't have to recalculate it again. Okay, now I'm just getting the current value, current index value. Okay, and this, ignore this race as of now, because I am just considering this into this as a part 2, and here I'm just checking if it is visible from the left. So this is just to check if visible from left, and same for this same for this one, to check if it is visible from the right, and to check if this is visible from the bottom, and check if this is visible from the top. So how this function is working? So if I go to the if I go to the okay, so if I go to this function check left, so here if you can see, so I have taken I and j. So I is the current row index, and j is the current column index, and this is the current index value. And here what I'm checking, here I'm checking if the I'm just iterating through current index minus 1 value to the zeroth column, zeroth index column. Okay, so I'm just iterating through the current row from the current index to the zeroth index. Okay, so for example, if I have taken this matrix as an example, so suppose here there are some values, some, and if I'm here, my I and j is pointing here, then if I want to check left, then I will go in this side. Okay, if I want to check right, then I will go this side. So here I will decrement here, and j will be constant. Here I will increment, and j will be constant. Same here, I will be constant and j will decrement. Why? Because this side row will decrement, this side column will decrement, this side column will increment, and this side row will increment. So here I will be constant and j will increment. Okay, so to check this condition, we have written this for loop. We have written this for loop: check left, check right, check top, and check bottom. And we are checking if any of the condition is true here, if you can see. So here we are just checking if any of the condition is true. If any of the condition is true and the current index is not in the visible set, then just append that current index to the visible set, and at the end just add whatever the length of this visible set to the total value. So initially total value was the total number of edges, edge tree present. Then I'm just adding total number of tree which is visible from the outside apart from the edge tree. So this is how part 1 is defined. I have mixed part 1 and part 2 in the same code, so that's why you are seeing this temp and something. So I will explain you what this temp is. So let me just walk you through the part 2 again. Okay, so let me just walk you through the part 2. So in the part 2, what it is saying, you have to find the Seneca score. So what is Seneca score? So Seneca score is basically you have to select one tree. You are not the edge tree, but inside apart from the edge tree. So which will be the under the jungle. So if you move to the any of the direction, so you have to check from how many number of tree, means how many distance you cover, so that current tree is visible. So what is the Seneca score? So here if you see the Seneca score, a tree Seneca score is found by multiplying it together, the viewing the distance in the 4 direction. Okay, so so Seneca score will be found if height of the all its neighbor tree is less if it is greater or equal to the height of the current tree, then it is going to be blocked. So we are just going to add the all height from the current tree to all its neighbor tree. So if I go to the code, so here if you see, I'm just adding the total number, I'm just counting total number of tree for which this condition is not true. If height is just less than the current tree height, if height is less than current tree height, then I'm adding it, and at the end, if this condition fails, then I'm returning it, and at the end I'm just multiplying it and calculating the maximum score. So that's why I have written temp everywhere, to calculate number of to calculate the distance from one tree to from the current tree to all its neighbor tree. Okay, and at the end I'm just calculating the maximum score and printing it. So this is how part 2 is working. So let me just run this program. So if I go to day 8, then run python 3 main.py. So if you see, for part 1 it is 1807. So if I go to part 1, it is 1807, and for part 2 it is 4,80,000. So for part 2 it is 4,80,000. Okay, so thank you so much for watching. I'm going to paste the solution in the description, so you can refer it for a reference. If you find a better solution, then you can definitely paste in the comment. Thank you so much for watching. Please like and subscribe to my channel. Thank you.